Hi, my name is Gina Maria Giordano, and I am doing my video today on the addition rule. So first, I want to start off by talking about mutual exclusivity. Two events, A and B, are mutually exclusive if they cannot occur at the same time. If the two events are not mutually exclusive, there would be an overlap in the two events in which A and B would occur. I found it very helpful during the video when they showed the example on the Venn diagrams. So mutual exclusive shows that A and B do not overlap, and if they are not mutually exclusive, it shows that they do overlap. For example, decide if the events are mutually exclusive. Event A, rolling even numbers on 2 die, and event B, the die having the sum of 7. So these events are mutually exclusive. And the reason for this is that you cannot roll 2 even numbers that have the sum of 7. Another example to decide if the events are mutually exclusive is if event A is drawing a king from a deck of cards and event B is drawing a heart from a deck of cards. These two events are not mutually exclusive. The reason for this is that it is possible to draw a king of hearts from a deck of cards. For the addition rule, if events A and B are not mutually exclusive, the probability is given by this formula. The probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. If the events A and B are mutually exclusive, the probability can be simplified to the probability of A or B equals the probability of A plus the probability of B. For example, in a group of 101 students, 40 are juniors, 50 are female, 22 are female juniors. Find the probability that a student picked from this group is either a junior or a female. So first, you want to start out by finding out if the data is mutually exclusive or not mutually exclusive. So looking back at the problem, we can tell that the data is not mutually exclusive. The reason for this is that the probability has the possible outcome of being a junior and a female. So knowing that the data is not mutually exclusive, you want to start by breaking down your formula. So since the data is not mutually exclusive, we're going to use the formula, the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. So to break down our formula, we are going to say that the probability of juniors or females equals the probability of junior, which is your A, plus the probability of your female, which is B, minus the probability of your juniors and females. Next, we want to plug in the information given from the example. So what we are going to do is we're going to look at the probability of junior plus the probability of female minus the probability of junior and females. So to get your probability of junior, you're going to look back into the problem and see that there are 40 juniors. So you're going to get 40 out of the 101 students. Then your probability of females is your 50 out of 101, because there are 50 females. Then you're going to minus your probability of juniors and females. So the problem states that there are 22 females and female juniors. Next, you're going to solve using the information you already know. So we already know that there are 40 out of 101 juniors, 50 out of 101 females, minus your 22 out of 101 junior females. And you get 68 out of 101. So 68 out of 101 students are juniors or female. Looking at another example, in a group of 101 students, 30 are freshmen and 41 are sophomores. Find the probability that a student picked from this group at random is either a freshman or a sophomore. So first, you're going to find out if the data is mutually exclusive or not. Looking back at the problem, you can see that the data is mutually exclusive. A student cannot be a freshman and a sophomore at the same time. Then you're going to break down your formula. So since we concluded the data is mutually exclusive, we're going to use the formula the probability of A or B equals the probability of A plus the probability of B. So your probability of freshmen or sophomores equals your probability of freshman, which is your A, plus your probability of sophomore, which is your B. Next, you want to plug in the information given from your example. So looking into the problem, we're going to see that our probability of freshmen is 30 out of 101 since it states that there are 30 freshmen. And your probability of sophomore is 41 out of 101, which is your probability of your sophomores. And that gives you 71 out of 101 students. 71 out of 101 students are freshmen or sophomores. And I hope you enjoyed.